again, our most valued student. My name is Confident. Welcome to our revision session of mechanical drives. This is part 3 of the lesson, and if this is your first time coming in contact with this channel, I will encourage you to subscribe to our channel as well as ensure that the notification bell is turned on. Why am I saying that? So that you can be notified every time there is a new video. Now, as I say, this is part 3. I've done part 1, I've done part 2. So if you're joining us for the first time, this is part 3. Go through the other videos so that you can be able to understand some of the foundations that I was laying concerning this channel on mechanical drives. And also, just to recap, remember, the chapter on mechanical drives is one of the chapters that carries good marks in your final exam. So if ever you master this area, you'll be in a better position for passing your exam. Now let's look at the other question now, if I can just dive into that. And this other question, I took it again from the previous paper. This is it's mostly question number 5, as you can see. So I took it from past exam paper, and I think this was last year, actually it's this year's paper if I'm not mistaken. So question 5.1, it says here, a clock watch has 2 gear drives with gear A driving gear B. The following is known. So whenever they give you this information, just want to show you, sometimes it's good to kind of sketch what is happening so that you can have a better understanding of this. So if I'm to sketch this, it says here, a clock watch has 2 gear drives. So we are talking about gear drives, right? So if I'm to sketch that, so I've got the smaller drive and I've got the bigger drives. They are touching each other. It's not going to be a smooth round. So this is how the gear drives are. And in these gear drives, what I have is the direction of rotation. If this gear drive is rotating this direction, the other one will be rotating in the opposite direction. They call that a couple. So that is what is happening. This is the direction of rotation. So when the smaller drive, this is the smaller, which is the driver. So if I can divide my line like let's say I have a division here like this. So what I have on the other side, I have my driver, and then this other side I have my driven. And then let's look at the information. Then it says a clock watch has 2 gear drives, gear A, and says with gear A driving gear B. So we've got gear A as the driver and gear B as the driven. So if I come here and say the driven is gear B, the driver is gear A. So now they give us information here about these 2 gears. It says NA, which is the rotational frequency or the rotational speed of gear A is 750 rotation per minute. So if I come here on the A, the information I've got NA as, so NA is equal to, it's capital A in this case, it is equal to 750 R per min. And then the other information that I'm given is TA, which is the teeth, the number of teeth. So the number of teeth in A is 25 teeth. So I write number of teeth in A is equal to 25 teeth. And then the other information, TP, which is the number of teeth in B, which is on the other side, is equal to 50 teeth. So this is the information that they give. So from this information, you can actually do quite a lot of other information that is not given here. So there is quite a lot of information that you can actually come out from this. The first one that I can come up from is the NA. Remember, if I look at the formulas here, just to show you this formula, to say if I'm given bigger N, I can convert the bigger N into the smaller n. Now the bigger n is in rotation per minute and the smaller n is in rotation per second. So which means it says here n is equal to, the smaller n is equal to the bigger n over 60. What am I doing? I'm converting it from rotation per minute to rotation per second. So if it's NA, it is equal to 750 over 60, and with that it can assist me then to, if I want to work with rotations per second, that's what I'll be using. So 750 divided by 60, this thing gives me 12,5. So I have now 12,5 rotations per second. Sometimes you might find that they strictly want to leave your answers in rotation per seconds or in rotation per minute, so you need to know how to convert that. So I've got that information, and there is another information that is important. It is this information for V. As you can see, it says V is equal to pi dn. But before I go ahead of myself, let's look at the questions. It says calculate, number 1, we need to calculate each of the following. 5.1.1, the rotational frequency of gear B. So what do they mean there when they say rotational frequency? They are talking about NB there. Remember, NA is the rotational frequency of gear A, so we need to find NB. Now, for us to be in a position to find NB, there are different ways that we can approach it, but the formula, now we're coming back to the formula that I was saying you need to have. Let's look at this formula here. It says NA.TA is equal to NB.TB. So that's what we're going to use. If I can use this formula here to say NA, the way it is written, to say NA times TA is equal to NB times TB. Are you seeing that? So I'm given the first part, NA and TA, which is 750 times TA is 25, is equal to NB, which is what I'm looking for, the rotational frequency of B, times 50. So now if you look, what I need is NB, and I'm multiplying. So the opposite of multiplication is division. You divide by what you don't want to remain with NB, meaning you divide by 50 on both sides. So when I do that, it will be in this case, if I use a calculator quickly, it's 750 times 25 over 50, and then it is going to give me 375. So I'm going to have NB being equal to, you can say therefore, because I'm interchanging here, 375. Remember, NB, the units there is rotation per minute. It's up to you. You can convert it into rotation per seconds. You know what to do. You use that formula which says NA, or N over 60, in this case is NB over 60, is equal to the smaller NB. So what you take is, you take this 375, you say 375 over 60, then you convert it to give your answer, in this case in rotation per second. So it's 375 divided by 60, and then you're going to get 6,25. So this is NB is equal to 6,25. Look at the units, rotation per second. So you can leave your answer like that, or you can leave your answer like that. It's still the same, whatever way it was going to give you the same answer. So that is the first question. Now let us look at the next question, 5.1.2. It says velocity ratio of the system. So VR, velocity ratio, you can use the thing VR there. So they want us to find the velocity ratio of the system. Now if you come back again to your formulas, and I just want to show you here on the formulas. Now this same formula that I'm using here, in as much as they didn't give you the velocity ratio, that formula actually gives us the velocity ratio. How do you go about this formula? NATA is equal to NB, there is a dot TB, even if you didn't write, but it's still the same. Now look at this. If I want to divide by NB dot TA over NB dot TA, what am I doing? I'm cancelling the TA this side, and I'm cancelling the NB this side. So you see what I'm doing? So here I'll be having NA over NB. See that? So A, that is the ratio of A is to B, is equal to TB over TA. But this ratio, or this fraction, is a special fraction. This is called our velocity ratio. This is what they mean when they say our VR. So when they're talking about velocity ratio, that's what they're saying. So you have got two ways of calculating it. You can either use to say VR is equal to NA over NB. I was just showing you how you can actually use it without cramming that formula. Now, what is our NA? We said our NA was 750 and our NB was 375. You need to maintain the units, so it's 750 over 375, and then you get the answer there. If you're going to divide that, so it will give us to say 750 divided by 375 is equal to 2. So you are seeing that this is 2, the answer that you get, but you say 2 is to 1. You must always leave your answer as a ratio form. It's 2 is to 1. If we are using the rotation per second, remember VR is equal to smaller NA over smaller NB. If I do that, it will be equal to, now the smaller NA, we did find out that it was 12,5. Remember, I did convert it earlier when I divided 750 divided by 60. So it's 12,5 here. 12,5 divided by 6,25. You seeing that? So it's when you are working in this case now with rotations per second. So you say 12,5 divided by 6,25. It must give us the same answer, which is 2. So the answer there is 2 is to 1. But now look at the question again. I mean the formulas I used. I say you can use either this formula or you can use it in terms of the number of teeth, which is TB over TA. So if I have to use that one to say VR is equal to TB over TA, which is the number of teeth in B, and we found that the number of teeth in B was 50 and the number of teeth in A is 25. So you can see that now it's 50 over 25. You know 25 into 50 is 2. So this is MS 2 is to 1. As you can see that. So that is different ways of calculating that velocity ratio. Alright, then the next question here says 5.2 says name 2 types of hoisting devices. Hoisting devices. Now when they're talking about hoisting devices, they're devices that can lift an object from one point to another, especially in a vertical position. To hoist is to take it from down and lift it up. So you have got different things here. We have got the differential. Most of them they start with that word differential. So you've got the differential wheel and axle. You need to know this one. You have got the differential winch. If you check your books, also it covers that. And then you have got the differential pulley block. It also covered in your book, differential pulley block. So these are covered in your book. You can also say another lifting device is simple, a crane. If you're stranded, you can use crane. And then you can use also say simple pulley system. A simple pulley system can even any marks. So you just need something that is simple. If ever you're stranded, to say you forgot the word differential wheel and axle, the differential wheel winch, as well as the differential pulley block. If you're forgetting, you can go for that. So now let's look at 5.3 here. And question 5.3, interestingly, they're talking about that. They are saying here a differential wheel and axle. So actually they gave you the answer for this question. I mean, they're asking you 2 types of hoisting devices. Already the first answer is differential wheel and axle. Is for you to remember. The other one again is differential winch. The other one is differential pulley block. So just remember, once you know the word differential, you know that I need 3 set of answers: the winch, the wheel and axle, as well as the pulley block. Alright, now they are saying here a differential wheel and axle device has a velocity ratio of that. The diameter 1 is that, diameter 2 is that, with a mass on effort of 60 kg. The mass on the load is 800 kg. Now calculate each of the following. You know, sometimes let me just do this. There is a question, actually, maybe just to say, that was actually asking students to draw the differential wheel and axle. It was not complicated, but it will help you to see how this was answered. If I can just quickly sketch that. So my diagram is not gonna be very accurate in a way, but this is a differential wheel and axle kind of a thing. So what you have is here, I wanted to mark it like this first before I do that. So what I have here is just a rough sketch of a differential wheel and axle. So basically this is what you're having, and you can have now your lines like that. These are the rope. So you've got the rope starting there, and then you have your rope here hanging with the load. I'll continue that one. So you have that. So this is the rope system, and then you have that. So what we have, you have it like that here, just to say this is the end of the rope. So here you have your pulley system here. Alright, as I'm saying, what you have, this is your effort. You need to know the differential wheel and axle. This is in this case your snatch block, your snatch block. But here it's your load. You see, I'm doing this so that a question came. It was a funny question that I saw where they were asking you to sketch this. So you have in here this distance, your big D, the distance of the wheel, and then you've got here your D2, which is the larger diameter, and we have got here your D1, which is the smaller diameter. So remember that. So now when the question is saying a differential wheel and axle has a velocity ratio of 20, now when they talk about the velocity ratio, I'm going to write that information though, to say, let's keep this to say VR is equal to 20 of this wheel and axle. Just the information we need. With D1 is that 300 millimeters. Remember, what you do is you take 300 millimeters. Milli means times 10 to the power negative 3. So in a way, if you do that, you'll get 0.3. It's like you're dividing 300 divided by 1000. Same as 240 is 0.24. This is now in meters. You must always work with meters. So they are saying D1 is 0.24 meters, and D2 is equal to in this case actually D1 is bigger. I made it smaller, so D1, this is actually my D1. Let me do this just to put an eraser here to say what I have is my D1 being bigger and my D2 being smaller. So this is bigger diameter, bigger D, and this is smaller D. So when I have that, let me come back and I say it says D1 is 300, which is 0.3. That is my D1 and my D2. So my D1, if I use another pen here, this is equal to 0.3 meters, and then my D2 is equal to 0.24 meters. Are you with me? And then they are saying the mass on the effort is 60 kg, so, and the mass on the load is 800 kg. So the effort here, they are saying 60 kg and the load is 800 kg. So that is the information that is given, but you must know how do I convert? Remember, when you're talking about effort and load, now effort is equal to the 60 times 9,8. Where do I get 9,8? It is the acceleration due to gravity. You must always know it's a force, so you cannot just leave it as 60. You must multiply it by the acceleration due to gravity. So when you get that, that is our effort. Even our load in this case will be 800 times 9,8. That is now in newtons. Okay, so the question, first one is 5.3.1. we need to find the mechanical advantage of machine. Now let's go to the formulas. If you look at the formulas, if I can just erase this to say where is the formula for the mechanical advantage, you find it up there. There is the formula for the mechanical advantage. It's load over effort, or L over E. So if I use that to say mechanical advantage, MA is equal to L over E, which is load over effort. Now the load is 800 times 9,8 over the effort is 60 times 9,8. So it will give us the mechanical advantage of this particular machine. So I have 800. You can even leave out, you can scratch out the 9,8 over 9,8. It's still going to give you the same answer, 60 times 9,8. Now if you look at that, it's 13.33. if you round it off, is 13,33. remember, there are no units. Why? Because it's Newton over Newton, and if you cancel that, you'll find that the units are cancelling. So that is the mechanical advantage of that machine. And then the next one, it says we need to find here, that was 2 marks. Now the 3 marks, we need to find the effort distance for 1 rev of the drum. They want the effort distance. So now if we are talking about the effort distance here, if I come back to the formulas, there is something that is linking us with the effort distance. And what is linking us with the effort distance, if you look, it is, there is SE, because SE is the distance moved by effort and SL is the distance moved by load. If I write that, and dr in this case is our velocity ratio. So if I say dr here is equal to distance moved by effort over distance moved by the load, right? But we need to find, the question here says find the distance, the effort distance, meaning the distance moved by effort, SE, for 1 rev of the drum. So if we want to find that SE, what they gave us, remember they said the velocity ratio was equal to 20. So that's very crucial information there. They did give us VR as 20. I did capture it there. So what we have is the dr there is your VR, velocity ratio. So we know that SE over SL is equal to the velocity ratio, which is equal to 20, right? And they want us to find the effort distance. So for you to find the effort distance, you can actually do it like this. If I can do it like that, to say, now it's mathematics, multiply by distance moved by load and multiply by distance moved by load. If you multiply, this will cancel. So you say distance moved by effort is equal to, because it was a fraction, for me to get rid of the fraction which was the distance moved by load, so it will be 20 times the distance moved by the load, which means I need to find what is the distance moved by load. Coming back again to our formula, you have the formula here. Just want to show you something on the formulas. When you are talking about the distance, there is this formula here which says 2d over d1 plus d2, d1 minus d2, where d1 is the larger diameter and d2 is the smaller diameter, and d is the diameter of the wheel. But if we look at the question, let's check if they gave us the diameter of the wheel. They says a differential wheel and axle has a velocity ratio of that with a diameter of that, and D1 is that, and D2 is that, with the mass of that. Now, they did not give us, in this case, they did not give us the bigger diameter. So what you have, as you say, you are forced now to use some of the information that you have in your textbook on how you calculate. So let me just remind you how you calculate. Remember, when you're calculating the distance moved by effort, you used pi d. And then when you're calculating the distance moved by load, what you had in here pi, you say d1 minus d2, and you divide it by 2. And when you combined this formula, you had VR, velocity ratio, was equal to, and then you had 2d over d1 minus d2. So this formula which you have here, this is the formula that I'm showing you to say 2d over d1 minus d2. This formula is the one that I just came up with here, but it was made from the distance moved by effort as well as the distance moved by load. So from that, that's how they derive to say here VR is equal to SE over SL. And if you do that, it will lead you to this particular formula. So now, which means in this formula, I'm looking now for SL, which I'm going to put there. So where there is SL, I'm going to put pi d1 minus d2 over 2. So then I will have SE is equal to 20 times pi. Then I've got d1 minus d2, and then divided by 2. Now remember, d1 we are given and d2 we are given. What are we given is d1. We are given d1 is 0,3 and d2 is 0,24. So that's what you substitute there to say in here, which is equal to 20 times pi 0.3 minus 0.24. You see that? Divided by 2. So that's what you'll be given there. Then this allows you then to use your calculator to get the final answer, to say it is 20 times fraction, then you've got pi, put that as 0,3 minus 0,24, and then divided by 2. But as I say, it is very important for you to consult your book or your textbook in that case. So look at the distance moved by effort is 1,8849, which is 1,88. But remember, we are measuring our distance in meters. Always work with this case in meters so that it can simplify things. So this is how you can, in a way, be able to calculate. But now, let's say you wanted to use, in this case, this formula on its own. Let's say you forgot about this formula. Let's say you forgot about how the formula was made and you are interested in using this formula. So if you're using this formula, what you're gonna have, where there is VR, remember I said VR is 20, is 2d over, we know our d1, it's 0,3 minus d2, which is 0,24. We can separate that, and 20 is equal to 2d. We are now calculating the big D because they didn't give us the big D. So if we calculate it, it will be 0,3 minus 0,24. If you calculate that, it will be 0,06. So you have over 0,06. And I think I showed you to say, if you want to now get rid of this fraction, you multiply by that fraction, which is 0,06, so that it goes. But what you do on the left, you do on the right, 0,06. So when you do that, we have got 20 times 0,06, 20 times 0,06, and then equal to, and then you get 1,2. So you've got 1,2 is equal to 2d. Divide both sides by 2 so that you can remain with d, and you'll see that d is 0,6 is equal to the big D. But remember, you are working with meters. So when you've got the big D, now you can then use this formula now. You remember, now you know the big D. You can then use this formula SE, look at this formula, SE is equal to pi d. So what you have now to say SE is equal to pi times d, and our d, we say it is 0.06, the big D. Then if you use that, it will then become pi times 0.06. Remember, you're working with meters. It will be actually, I think it was 0.6, not 0.06. It's actually 0.6, not 0.06. That's why it's giving me a smaller answer now. So if I use that, it is then going to give me, I think, a similar answer of 1, if I say pi times 0.6, it's giving me 1.88 meters. So that was the same answer that I got in this case up there. So alright, so that is the part. And then the next one, 5.3.3, it wants us to find the efficiency of the machine. So we're looking now at the efficiency, and there is a formula for that. And the formula for efficiency, there is the formula for efficiency here to say this formula is actually doing efficiency. So HV over VV times 100 is equal to, that sign means efficiency. Now efficiency is equal to MA over DR. Remember, DR means velocity ratio. So that efficiency is equal to MA over VR times 100. You see that? Where the DR is the VR. So if I use that formula here to say efficiency is equal to mechanical advantage over velocity ratio times 100 and percent. Efficiency is measured in percent. Now the mechanical advantage that we got, remember, it was 13.33. That was the mechanical advantage, which is 13.33 over the velocity ratio. They gave us, they said it was 20. They said VR was equal to 20 times 100%. So your answer will always be in percent, because whenever you're talking about efficiency is in percentage. So it's 13.33 over 20, and remember you multiply by 100, and then equal to, press ST, it's 66.65. so this is 66.65, there it is, percent. So that is how you find the efficiency. And then guys, if you look at this, this is a cool 257 marks. You get a cool 7 marks out of this. It wasn't really difficult, but if you have studied the differential wheel and axle, you'll be able to do that. Now look at this guys, I'm not going to do 5.4 because in the previous lessons, in lesson 1 and lesson 2, I covered in detail a question similar to 5.4. Now this is for today your homework. Try this question, give me a feedback. Remember, it is the one that I'm actually using as my front page here to say there is the slack side and then there is the tight side, T1 and T2. So exactly what I'm giving you on the front page is what you have here. So they are telling a tension ratio of the tight side force to the slack side force of a belt is 5,1, and the force in the slack side is 500 newtons. The driving pulley has a diameter of that and the rotational frequency of that. So as I said, you are having that and you are having that. You are having your slack side and you are having your tight side. So this is your T2, this is your T1, you have D1, this is diameter, and then here you have your D2, direction of rotation, and this is the speed of the belt, which is your V, and this is the speed of the belt, that is your V. So you used all this information that is given, you'll be able to do 5.4.1, the speed of the belt, and 5.4.2, the power transmitted. Just give it a try. Give me your feedback. If you're struggling, I'll have a session whereby I'll try to answer for you this question so that you can be able to see without me assisting you, are you able to answer that. Guys, we've come to the end of our lesson. Remember to subscribe to our channel, follow us, and give us some comments, give us some feedback, ideas. Anything from you guys is worth it because it tells us there are people watching and benefiting from this channel. I hope this was of benefit to you. Please remember to also share this channel to your friends and your colleagues. Thank you.